Hello everyone, in this video I'm gonna talk about Kubernetes. We are going to learn how to deploy this very simple web application to what is known as a Kubernetes cluster. We are also going to learn how to create multiple Kubernetes objects along the way. So some of the prerequisites that I expect from you before taking this tutorial is that I expect that you have some knowledge in building web applications. In my case, I'm gonna build my application using Node.js and Express.js. I also expect you to know some Docker. You don't need to be a Docker expert to take this tutorial because it's made for beginners, but I expect you to know what the Docker is, what Docker image is, or Docker container is. So if you don't know these terms, please go to Google or ChatGPT or maybe YouTube and learn about these terms and what they mean. After that, you can come back to this tutorial and continue watching and to get the most out of it. So now let's see some of the setup and the tools I have running on my system. You can see in front of me I have VS Code running, some code base. This entire code base, by the way, will be available on my GitHub repository. This GitHub repository I will link to it down in the description box. So make sure to check it and to fork it to your system and to copy or clone the project to your hard drive and start working along this tutorial. I also have in front of me running is my blog post about Kubernetes. This blog post, by the way, is kind of mimic the tutorial, but it goes more in details. So I encourage you to go through the entire blog post to learn more about Kubernetes. And also I have more theoretical knowledge to deepen your understanding, so make sure to go through that. I will link to this video also in this section here. You can see still, because the video is not ready yet. So as soon as it's ready, it will be embedded from YouTube into my blog post. I also have some PowerPoint slides to explain some of the complexities of Kubernetes, because I want you to have a very deep and strong knowledge of the fundamentals of Kubernetes. I also have Docker running, because without Docker there is no Kubernetes. So you need to install Docker. Just go to Google, search for Docker, install Windows or Mac or whatever, and install it on your system. After you install Docker, it's gonna by default when you run Docker, the Docker client or Docker desktop as it's called, the engine will be running by default, but the Kubernetes will not be running by default. So you need to go to settings and search for Kubernetes on the left hand side and click enable Kubernetes, and after that just click apply and restart, and it will take some time to start Kubernetes and start it on your system. Now just a couple of warnings here. Kubernetes and Docker will eat all of your RAM. So if you are running out of RAM and if you are experiencing any lagging or your system is slow or whatever, just know that it is because of Docker and because of Kubernetes. And now the more containers you create or the more Docker objects you create, the slower it's gonna be. So in this tutorial, we're not gonna make anything complex like a microservice architecture, but we are going to create something very simple. So I hope nothing bad happens for your RAM and your computer speed. So that's the warning. I also I'm gonna tell you that Kubernetes will take some time in order to start. So don't lose your patience. Don't be intimidated by the time it will take to install or to run Kubernetes. So that's it. Now let's get back to Kubernetes and understand what this tool is and why it is useful. Now you might ask yourself, if we have a very simple web application, in my case this one, by the way, this application runs on port 3000 and it has this very simple structure. Like it has only one endpoint. This endpoint is get posts. So the purpose of it is just to return, I forgot the word return here. So its purpose is just to return this array, okay, this array of objects as JSON to the client. So that's it. It's very, very, very simple. And for this simple application, why are we going to use Kubernetes and use, if you see at the diagram, it has some complex structure. So why we are going to use Kubernetes in this case? Now, let me tell you, for a simple application like that, we can containerize the application and deploy this cluster inside AWS, for example. Yeah, it works, but what if we have a complex architecture like in microservices? In microservices, every service has to be containerized in a single container. And there is no way to allow Docker, for example, to make communications between these containers or facilitate the management of these containers. So for this purpose, we have Kubernetes. The purpose of Kubernetes is to facilitate and the management of containers and make communication or data communication between the containers easy. So that's it. That's the purpose of Kubernetes. So I have in front of me some diagrams to explain what some of the complexities of Kubernetes. So when we run Kubernetes or Docker on our system, we are basically running what is called a cluster. So inside this cluster, we have also nodes. Nodes are just virtual machines that host our files in order to make the application up and running. And also in a production environment, this cluster will be deployed in some cloud provider like AWS or Google Cloud or Azure or whatever. But since we are running Kubernetes on our local system, we are going to have a single node. We don't have multiple nodes. There is a single node running now on your system. Now let's see what is inside this node. Inside this node, we have multiple objects. Okay, we have different types of objects inside Kubernetes. We can create our custom objects as well, but in this case, we have this object. The first object we are going to learn about is called pod. And a pod is simply just a running container. A running container I mean by it that we can host multiple containers inside this pod, but we usually do one pod for one container. So we don't do multiple containers inside a single pod. So that's it. And also we have another object called deployment. And the purpose of this deployment is to manage pods. So you can see in my case, I have this structure where I have two pods. And these two pods have inside them this container, and this container is called a post. So I want to tell this deployment object to manage these pods. How I'm gonna tell it to manage these pods? I'm gonna attach a label, this thing called a label. I'm gonna attach a label to this pod, and later I will tell this deployment to manage every pod that has this label, app:posts. So any pod that has this label will be managed by this deployment. And in this case, for example, I have two pods running here, and these two pods have different labels. In this case, it's app:auth. So anytime I wanted to say to this deployment, anytime you see a pod with this label, app:auth, I want you to manage it. Now, what do I mean by manage it? What is this management of pods? Management of pods, I mean by it is that let's suppose for some reason that this pod disappeared. Okay, this pod disappeared or crashed. This application is crashed because basically inside the pod there is a container, and inside the container is an application. So let's suppose that this application or this pod disappeared or crashed for some reason. The purpose of deployment is to automatically recreate the pod for us and rebuild the connection with it and rebuild any other connection with other pods and so on. So that's the purpose of deployment. And it happens automatically. We don't need to do anything. And I'm going to show you in this tutorial how and prove to you how deployment can recreate a pod. So stay tuned for that. Another thing that the deployment does for managing pods is that let's suppose that you decided to update the code inside this container or this Docker container. Maybe you added a feature, maybe you removed some feature. So you modified the code base inside this container. Now I want the deployment to know about these changes, and I want my clients or my web browsers to see the latest features or the latest updates that happen to my application. And that's the purpose of deployment. It automatically detects the changes made to your containers or to your pods and rebuild these connections with these new code bases or new updates or modifications. So for the purpose of this video or this tutorial, since it's very beginner, I'm gonna create a very simple structure, which is a single pod and a single container and a single pod, a single container and a single deployment. And I'm also gonna create something else called a service. So the purpose of the service is to allow communication from the outside world. From a web browser, I want to allow communication to this container, because we can't connect to this container by magic by running, for example, localhost /:, because this container is totally isolated from our system because it's running inside its own virtual machine. So there is no way to reach into this container without some facility. In this case, it's the service. It's called a service. So we're gonna learn how to build these three objects: service, pod, and a deployment. So in order to create these objects, I'm gonna first start by building the container, because that's the logical step. Without a container, we don't have a pod. Without a pod, we don't have a deployment, and there is no purpose of creating a service for nothing. So, the first step is to create this container. In order to create a Docker container, we need to create a Docker image. And in order to create a Docker image, we need a Docker file. So I have in my root directory a Docker file running here. I'm not gonna explain the instructions inside this file, but I'm gonna tell you that I already added some comments for you so that you understand what each line means. By the way, this entire file basically means that hey Docker, I want you to copy everything inside this directory from my local machine to the container. So that's the purpose of it. After copying everything else, I want you to install the packages, and also I want you to run npm start. So that's basically it. I'm just mimicking how this application is running on my system, but I want to mimic that inside the container through this Docker file. So anyway, let's start creating this container or this image. So to create a Docker image, we run docker run. First of all, I need to go back to my root directory. I'm gonna say docker build -t. I'm gonna give it a name for my Docker image, which is markmaxi/test and period. Period just means that I want you to look inside this running directory. I want to look for the Docker file and build an image from that Docker file. So click enter. And you can see it's running now. Okay, after it's finished building the image, I want to push that image to my Docker hub, because later Kubernetes or Docker will look for this image on my Docker hub. So docker push markmaxi test. That's it. Okay, now it's ready. Now it's time to create. We created an image. Now it's time to create a container. But I'm not going to create a container directly from some Docker command. But what I'm going to do is I'm going to build a deployment. And this deployment will create a pod for me. And at the same time, it's going to create a container for me. So I'm going to get 3 in 1. So let's see how to get 3 in 1. To create a Docker deployment, we need some configuration file, because we need to tell Kubernetes what pod to manage, what is the name of the pod, what is the name of the deployment or whatever. So we need some configuration file. Well, to create this configuration file, I'm going to go to the root directory of my application and create a folder called infra for infrastructure. Inside this infrastructure, I'm going to create another subfolder called Kubernetes, or for short K8s. Inside Kubernetes subfolder, I'm going to create a file called post deployment, or post depl, let's say, for short YAML. And inside this YAML file, I'm going to create some instructions or some configurations. In order to save some time, I already have this file ready for you, so you just copy paste it basically. Let's see where it is in my blog. So that's it. I copied the code and went here and paste. So let's understand some of the lines that are running here. We have in the first line, by the way, I encourage you to go to extensions and install the Kubernetes extension, so that you get, whenever you hover over any command here, you just see some description in case you forgot. So I'm gonna explain some of things. The first thing is API version. API version is just to tell Kubernetes where to look, in what package to look in order to install this or to create this object. In my case, it's a deployment. So I want you to look inside apps v1. Also, what kind of object I want to create is a deployment. I want to attach a name to this deployment, which is posts depl. Also, we have some specifications here for my deployment. In my case, it means replicas 1. I want to create a single pod basically, and also I want you to manage every pod that has this label, okay, or any pod that matches this label, app posts. If you remember from the diagram, I want this deployment to manage any pod with this label, app posts. So basically that's it. After that, we have some configurations for my pod. So I want this pod, the single pod I created here, I want this pod to have this label, app:posts. And also at the end, we have configurations for my container. The container, I want to build this container from this image that I have created recently and pushed it to Docker Hub. So I want to create the container from this image, and I also want to call it posts. What else? So I want to add some notes here about what this label and this label, how we add it to pod, and this deployment manages this label, or the pods with this label. So I want you to imagine or to think about it like in HTML and CSS. In HTML and CSS, basically you have HTML elements, and inside these elements you can add class names to each element, and you can use these class names by CSS in order to target the elements and add some styling. For example, you can add background color, change the font type, or whatever. So in my case also, I have this class name or label or whatever it is. I have it attached to my pod, and I'm gonna use this label to target it by the deployment. So in my case, deployment is CSS and pod is HTML, and this label is the class name. So I'm gonna use this analogy just to make things simpler and make things more memorizable for you in order to understand this complexity. So now we have created the deployment YAML file. Now it's time to tell Kubernetes to use this file in order to build the 3-in-1, the deployment, the pod, and finally the container. So how to do that? First, I need to move to my infrastructure folder and then to Kubernetes. And inside of here, I'm gonna run a command called kubectl apply -f posts. Okay, post depl .yaml and click enter. You see here it's deployment created. So I have basically, theoretically, I have the deployment running, I have my pods running, and I have my container running. So I need to test all these three elements. Okay, I want to test these three elements that they are indeed running on my system. So let's see if deployment is running. To see that, we run a command called kubectl get deployments. Now I have basically more deployments running in the background because I created these deployments yesterday working on another project, so ignore these and just focus on the last line, which is post/depl. So post/depl is basically the deployment that we have created recently. It was created 33 seconds ago. So that's it. And I know it's running because it's ready and up to date and available. Also, what else? Let's see if the pod is ready. To get the pod, we run the same command, kubectl get pods. Also, you can see 72 seconds ago, we have this pod running with this ID or its name. Okay, it has a certain name, post/depl/something. So I'm gonna copy this name here because I'm gonna use it now. Now let's see. We have tested the deployment, we have tested the pod. Now it's time to test the container and see if the container is running. And in order to see the container is running, remember that inside this container we have an application. And inside this application, we have this log, this console log. So in order to test that this application is running, I want to see the logs of this container. Okay, so in order to see the log of this container or the log of this pod, I'm gonna run this simple command, which is kubectl logs, and then the name of the pod I want to see its logs. In my case, it's this pod. Click enter, and it's listening on port 3000. So let's go to port 3000. There is some error. We can't connect to localhost 3000. Why is that? The reason is very simple. We are running the application inside the container, and this container is a virtual machine. It's totally separate from our local system, so there is no way by any means to reach this container just by running some port of 3000. It's not magic. So we need another object or another tool to facilitate the communication between the browser or client and the container. So in order to make that connection possible, we are going to create something called a service. So, but by the way, at least we know that the log is running, so my application is running, so my pod and my container are running fine. Now it's time to create the service to connect to this container from the browser. So in order to create a service, I'm gonna create another configuration file and tell Kubernetes to use this configuration file in order to build the service. So I'm gonna go to infrastructure Kubernetes and create another file called posts-service or SRV or whatever, but usually it's called SRV. So post SRV YAML file. Now we are going to create or to add some instructions for Kubernetes, but these instructions, you can find it on my blog post. If we go down here, I'm gonna copy this and go to my VS Code and paste. So basically it's very simple file. The first line is API version v1, as I told you before, what kind of service what kind of object I'm gonna create. It's a service, and then add some name to this service. By the way, the names are for logging purposes only, so that's it. And also what kind of type, because services have many types. I'm gonna tell you now. after finishing these lines. So basically we have different types of services, and in my case I'm gonna create a node service. Also, what else? The selector. I want this service to expose any pod with this label. Okay, any pod with this label will be exposed by this NodePort to the browser. Also, I want to use port 3000. I'm gonna explain these two lines later. Just trust me and add 3000 in here. So anyway, let's see now the types of services we have. Because I told you that we are going to create a NodePort service. So we have different services inside Kubernetes. The first one I chose is cluster IP. Cluster IP is a service whose responsibility is to facilitate the communication between the pods. So if I want an auth service, if I want an auth pod to communicate with the posts pod, this communication happens by the cluster IP service. So but in my case we don't have different services, so it doesn't make sense to create a cluster IP, right? The second example is a NodePort service. NodePort service, as I told you, is make a pod. Its job is to make a service accessible from the outside of the cluster, usually used for development purposes. We don't use this for production. In production, we create something called a load balancer. So a load balancer is the same. Its job is the same as the NodePort. Its purpose is to expose our node or our pods to the outside world, but it's outside the scope of this tutorial. But if you want me to create another tutorial to show you how load balancers work, or how to create the load balancer, yeah, please write a comment in the comments section so that I can create some tutorial about that. So that's a load balancer. I want to add here in a production environment. Okay. So what else? Now we have created this configuration file. We need to tell Kubernetes to use this file in order to create the service or the NodePort service. How to do that? kubectl apply -f posts service.yaml and enter. You can see it's created. So we already created these three and we tested each object. Now we have created this NodePort service. Now it's time to test this service. So how to test it? Yeah, I think you guessed it right. In order to test this service, if it's running or not, we are going to connect to our container from a web browser. So let's see if that will work or not. Assuming the container is running, I'm gonna go to localhost 3000 and click refresh. Okay, nothing happens if you know why, because inside index.js we don't have anything running in apt-get posts. So I'm gonna go to posts and see. Still not running. The reason behind that is because the service is running on a different port. Let me show you. If I go to kubectl get services, I see different services. These services are created earlier, so just ignore them. Okay, I'm gonna look at the last line, which is post service, which is a NodePort, and this NodePort is running on this port. Okay, so I'm gonna copy this port 30251. In your case, of course, it's something different because it's a random process, so I can't anticipate what kind of port it's gonna create or what number it's gonna create. So I'm gonna go here and paste it and click enter. You see, it's up and running. So I already got my response back. So I know for sure that my application and my container are running, and I managed to get from a web browser. Okay, let's see here, this diagram. I managed to get from this web browser into the cluster, into the container. It's something amazing. Now, I'm gonna explain some of the things that we already ignored probably. The port here and the port here and the port here. Why do we have 3 ports? The reason is very simple. So I'm gonna copy this. Okay, now I want to paste it here and paste it here. So basically, when we created service and we connected to this service, we connected to this port. This port is the port of the node. Okay, when we connected from our web browser, we basically made a connection to the node, and this node, as I told you, is hosted inside this cluster. And this cluster is basically just the Kubernetes running in the background. Okay, so we made a connection to the node, and this request or this connection was forwarded to the service. The service is running on port 3000 in my case. I don't know why I wrote 4000, but the request was forwarded to NodePort service port, which is 3000. And if you see from my code, that's the line that defines this port. Okay, and this request is also forwarded back to the container. The container runs on port 3000, and that's this line, target port. So it's forwarded to this to the pod. Basically, this should go to here. So excuse me for inconvenience, but this port is for the pod. Okay, so basically the connection or the request was forwarded to the pod, and the pod has the container running, and we managed to get the communication between the browser and the container through this workflow. Now we have learned how to create a deployment, a pod, a NodePort service, and how to connect to all of that from a web browser. Now there is something that I told you in the introduction, but I never did in the tutorial yet. And that is, I want to test the job of the deployment. I already told you that the deployment is responsible for managing a pod. So in case a pod is crashed, for example, in case a pod is crashed, the deployment is responsible for recreating this pod. So let's test that. I want to go here and run kubectl delete. Oh, sorry, before deleting, I need to get the name of the pod. So I want to run kubectl get pods and copy this one, kubectl delete this pod. Okay, I want to delete the pod. Oh, sorry. Oh, okay, so I forgot a keyword, which is delete pod. Okay, it's deleted. I want to now quickly run the command kubectl get pods. You can see now the old pod is terminating. Terminating means it's being destroyed, and in the meantime, the Kubernetes cluster created this this new pod, which is also called post-depl, but with a different ID, and it's up and running, and soon it's gonna be available. Let's see again. Okay, it's running, and the terminated pod is no longer running, or it's no longer there. It's completely destroyed and completely deleted from the cluster. So that's the first job of the deployment. Now let's see the second job of the deployment. Let's test how a deployment can detect changes made to our container. So let's make some changes to our code base and see if these changes will reflect in the browser or not. So what I'm gonna do is go to my index.js and add another endpoint, which is get/endpoint, and here I want to return res.send because I want to send a very simple hello world message. Okay, and see if this is reflected or not. So let's go back to the browser /endpoint and see if it's up and running. Okay, it says cannot get /. The reason is because we have made some changes to my code base, but all my changes are made on my local system. It's not made on the container, and if you remember, we are connected to the container, so there is no way, it's not magic that anything I change in my hard drive will be reflected on the container. We need to rebuild the container from scratch, and after that Kubernetes will detect these changes. So there are some steps we need to follow. I think it's above in my blog here. Yeah, so that's updating deployment. And the first step is to make sure that we are running the latest tag on the image. And if you remember, in my image, sorry, not here, I'm running the latest. Okay, latest markmaxi/test latest, because I want the latest updates about my image to be deployed to the cluster. So that's the first step, is already done. The second update I want to create is to update my code base in some way. I already updated my code base. I added this endpoint. So step 2 is done. Step 3 is rebuild the image. To rebuild the image, we basically run the same command, which is docker build -t /test, and we need, in this case, I want to go back 2 steps to the root directory and click enter, because that's where my Docker file is there. It's being rebuilt. Okay, step 3 is done. Step 4, push the image to Docker Hub. So docker push, what's the name of my image, which is markmaxi/test, and push it to Docker Hub. It's being pushed now. The last command to run is kubectl rollout restart deployment, and then the name of the deployment. I'm gonna copy this. If you remember, the name of my deployment is posts/depl. So I'm gonna copy this post/depl name and paste it in here and click enter. Okay, it says restarted. The deployment is restarted. So just to make sure that it restarted, I go to kubectl get pods. You see, okay, it's a container creating, so we need to wait a little bit until this finishes and it says running. So now you can see from the logs, in the previous time, it says it's terminating because this pod is being terminated, because the deployment detected the changes I have made to my container. So it had to destroy the old pod and recreate another one, which is this one. And you can see here it's up and running and it's ready to listen to my changes. So let's go to my /endpoint and see if my changes are reflected. Hello world. You can see, so any changes I have made to my container is reflected inside the pod and is reflected thanks to the deployment that we have created. So that's it for this tutorial. I hope you like it, and if you did, please click the like button and subscribe to my channel to get more videos like this, and share this video with your nerd friends. I know developers don't have friends, but make the effort. Also, make sure to go through the entire blog post I have linked to inside the description box and make some comments down below so that I know what kind of content you want to see in the future, and also for the YouTube algorithm. Thanks for watching and see you very soon.